Hi, I'm Miss Van Loan, and in this video, we're going to complete Module 4, Lesson 2, Independent Practice. I've already made a copy of my document. You can see it says copy of. I'm going to go ahead and take out copy of and put my name, Miss V. You should put your name and also type your name here. And then we'll scroll down to the first question. This is asking about proportional relationships, and when we're looking at proportional relationships on a graph, we're going to be looking for three things. We want to know, is it going in the upwards direction, which we see 3 of these graphs are going in the upwards direction. This one is not, it's coming in the downwards direction. And we're looking at this from left to right. So we have 3 that are going in the upwards direction. That's our first thing to look at. The second thing to look at is it a straight line? B and D are definitely straight lines. A, it's a little wonky. And if we compare it to B and D, it's definitely not straight. So we're going to throw that one out. Finally, we want to know, is it going through the origin? Remember, on a graph, we have the x-axis and a y-axis, and where they cross is called the origin. And the origin has coordinates 0, 0. Whenever you're writing coordinates, you always put the x coordinate, comma, y coordinate, and then they need to be surrounded by parentheses. So if I was going to write the coordinate 5, 2, which would be 5 on the x-axis and 2 on the y-axis, which would be this point right here, then I would put parentheses 5, 2, close parentheses. So just a quick reminder there. So the answer is going to be graph D is a proportional relationship because it is a straight line through 0, 0. Okay, let's move on to number 2. And you may notice that I have Desmos up here, and that is because we will be graphing these data sets in number 2. So which data set represents a proportional relationship between x and y? How do you know? So we're going to try graphing. And I just went to desmos.com. I clicked Math Tools, Graphing Calculator, and then I clicked the plus button and typed in, and then clicked Table. So I'm going to go ahead and enter the data set that I see here for red. So this is 1, and then the y is 8. And let's just enter the rest of the x's, 1, 2, 3, 4, 8, 9, 10, 11. And looking at this line, if I were to connect it, does that look like it's going to go through 0? No. So that one is not a proportional relationship. Let's look at the second one. Let's go ahead and add another table. 1, 2, 3, 4. This time we'll do the green data set, and this is 7, 14, 21, 28. And we are unable to see some of these bigger numbers, so let's zoom out. I can click this button to turn off the first graph, and okay, if you click that little magnifying glass in the bottom left of the data set here, it actually made the graph fit better. And it looks like this one, it might go through 0, 0. It's a little hard to tell. So what we can do is we can work backwards. 4, 3, 2, 1. The next data set above this would be 0, right? 0 and something. This is 1, 2, 3, 4. 28, 21, 14, 7. So if we work backwards here to see, okay, what's y when x is 0? 28 minus 7 is 21, minus 7 is 14, minus 7 is 7, 7 minus 7 is 0. So this will actually go through the 0.00. So the green data set is a proportional relationship. The green data set is a proportional, let's go up, prop-relat for proportional relationship, because I need to fill out the Y. But let's go ahead and double check these other two, the blue data set and the yellow data set. So let's turn that off. We'll add another table. And let's leave a spot for a 0. And I'm going to do the blue one right now. So 1, 2, 3, 4, 27, 20, 13, 6. And this one also looks like it might go through 0, 0. So I'm glad I left myself some room here. So 27 minus 7 is 20. Minus 7 would be 13. Minus 7 is 6. So you can see that we've got this trend here of them being 7 apart. But if we work backwards from 6 minus 7, we're going to get -1. So that is not going through 0. So blue data set is also a no-go. Let's look at the yellow data set. We'll turn that off, add another table. Let's leave room for 0 again, just in case. 1, 2, 3, and 4. 4 is partnered with 29, 3 is partnered with 22, 2 is partnered with 15, and 1 is partnered with 8. And again, it looks like it might go through 0. It might go just above 0. Let's double check. 29 minus 7 will be 22. Minus 7 is 15. 15 minus 7 is 8. 8 minus 7 is 1. So that's not going to go through 0, 0. So yellow is also not a proportional relationship. So the only one that is the green data set. The green data set is a proportional relationship because it is a straight line through 0, 0. Okay. Let's look at the data sets in number 3. And I can just quickly cancel these out and add a new table. And here we go. -5, -2, 2, 5, -6, -3, 1, 4. And then let's click the little zoom fit. And it kind of looks like this is going to go below the origin. It looks like it's going to cross right down here. Do you see that? So I don't think that the red data set is a proportional relationship. So let's close that one. Let's do this next one. The green data set, -5, -2, 2, 5, 6, 3, -1, and -4. Just double check that you're partnering the same numbers together. -5 with -4, -2 with -1, etc. And this looks like it goes just above 0. So that's not going to be a proportional relationship. Let's try the blue data set. -5, -2, 2, 5. -5, -2, 2, 5. And this one looks like it is going to go exactly through 0. Do you see that? How it lines up perfectly? So I would say blue is a proportional relationship. Let's check the yellow real quick. Oh, I put it up here. Okay. -5, -2, 2, 5, 5, 2, 2, 5. So this is coming down at an angle, and it might be a parabola, it might be a absolute value, which would be pointy. So we're not really sure. We don't have enough information here to figure out exactly what this graph is, but it's not a straight line. It's going up one direction and up another direction. So the only one in number 3 that is a proportional relationship is the blue data set. So the blue data set is the only prop-relat proportional relationship because it is a straight line through 0. Okay, which graph represents a proportional relationship between x and y? How do you know? Well, A is not straight, so that's not it. C does not go through 0, 0, so that's not it. B is not a completely straight line. This is actually an absolute value graph. And so that is not a proportional relationship. And D is a straight line going up through 0. So that is the only one. So graph D is a prop-relat because it is a straight line going up through 0, 0. Okay, are the ratios 12 to 30 and 20 to 45 equivalent? How do you know? So if we're looking at equivalent ratios, we can also write this like equivalent fractions. Let me make this a little bigger and I'll zoom in here. So let's do insert equation and we'll write this as a fraction. Oh, it's right there, new equation. Gotcha. Okay, math operations, we want a fraction. So this is 12 to 30, that's the ratio. And we want to know, is it equal to this other ratio? And remember, a ratio can be written as a fraction. 20 over 45. So it's written like a score right now, but we can also write it as two fractions that we're comparing. Let's see. These both have 15s. This is 2 times 15. This is 3 times 15. And 45 can be divided by 5. 30 can be divided by 5. Let's see if we can get a common denominator to compare these. We want to see if these are equivalent fractions. So let's simplify them to their most basic forms each. I'm just going to copy and paste it over here. And 12 divided by 6 is 2. 30 divided by 6 is 5. Okay. So 12 divided by 6 is 2. 30 divided by 6 is 5. 20 and 5. So, sorry, 20 and 45. 20 divided by 5 is 4. And 45 divided by 5 is 9. Okay. So is 2/5 equivalent or equal to 4/9? No. These are not equivalent ratios. Right? Because if we simplify them all the way, we should be able to simplify them to be the exact same number. And they're not. This is 2/5. And if we double it, it would be 4/10. And this is 4/9. That's not the same. Okay. Does the following table represent a proportional relationship? Why or why not? Well, let's plug it in and see. So let's just clear this out and use this one. Okay. -4, -8, -2, -4, 0, 0. Well, it goes through 0, 0, so that's good. 2 and 4, 4 and 8. And yep, let's hit this button. That looks like it is a straight line through 0. So yes, it is a straight line through 0, 0. All right, let's do number 7. Does the following graph represent a proportional relationship? Why or why not? Well, it is a straight line through 0, but we normally don't see proportional relationships represented as a negative line, because when we're talking about proportional relationships, we're usually talking about things in real life. And so normally we don't talk about them as negatives. So we can say that yes, this is technically a negative proportional relationship because the line is straight through 0, 0, but it is going down. All right, does the following graph represent a proportional relationship? Why or why not? What's going on here? It's a straight line going up, but does not go through 0. So no, this is not a prop relat because it does not go through the origin. Okay, does the following table represent a proportional relationship? Why or why not? Let's just use this table right here, and we'll see. Let's leave a spot for 0 in case we need it. 1, 2, 3, 4, 5. 1 is $75, 2 is $120, 3 is $165, 4 is $210, and 5 is $255. We'll hit this little zoom button, and we see this line, and it looks like it's going to cross somewhere over here, above the 0. We could figure that number out by working backwards. 255 minus something will give us 210. 255 minus 210 is 45. So let's see if 210 minus 45 is 165. 210 minus 45, yep, is 165. Minus 45, 120, minus 45, 75, minus 45 is 30. So we can fill that in, and we can see that this does not go through the origin. So no, the line does not go through the origin. Does the equation y equals 3x plus 6 represent a proportional relationship? Why or why not? So let's look at this one where it says f of x expression, and we're going to type in y equals 3x plus 6, and let's turn that one off, and we can kind of zoom out here, look at this graph, and it is not going through 0, 0, it's going through something above 0, 0. So how can you solve this if you don't have Desmos up? Because I don't think you're going to be able to use Desmos on the test. Well, you'll need to plug in 1, 2, 3, 4. Oh, actually, let's do 0, 1, 2, 3, 4, 5. Okay, so when we plug in a 0 for x, it would be 3 times 0 plus 6. That's what y will be. So y equals 3 times 0 plus 6. Y equals 3 times 0 plus 6. And that will give us our first value of y equals 6 when x is 0. Okay, so what about if x is 1? Y equals 3 times 1 plus 6. So y equals 3 plus 6, which equals 9. So that one would be 9. And we'll just continue like this. Y equals 3 times our next x, which will be 2. 3 times 2 plus 6. So y equals 3 times 2 is 6 plus 6. So that is y equals 12. Okay. The next one. Y equals 3 times 3 plus 6. Y equals 9 plus 6. Y equals, what's 9 plus 6? 15. Okay, so 6, 9, 12, 15. It looks like we're going up by 3s. So yes, we're going up by 3s, so that'll be 21. Okay, and we can zoom out a little bit, or actually we'll hit this button here, and we can see it goes through 6, and now we can see that this line is the exact same as these points that we put in the chart, because that's how we got the points. So there they are. We can turn that line on and off, and it's going through those points. So it does not go through 0, 0. That's the main thing. So I'm just going to leave my work down there, and I'll just say, no, this is not a prop for proportional relat relationship because it does not pass through the origin, otherwise known as 0, 0 down here. And that's it. We can go ahead and submit this assignment. Thanks, guys. Have a great day.